Welcome to the 2017 Spring Capstone presentations. We're doing the first of 6 presentations for you here today. Each presentation is going to be about 20 minutes long. We'll have about 5 minutes for questions afterwards, and then about 5 minutes in between, just for like shuffle time. We're all going to be watching the clocks as teams just to make sure we stay on schedule, and of course we ask you to do too, so we get done on time, but more importantly, so we make it happy hour on time afterwards. So, without further ado, we are building a HIPAA-compliant network for Stark Dental Clinic Group. My name is Corey Schaaf. I am the team lead and network administrator.
I'm Travis Vanderbiggin, and I'm the server administrator.
My name is Zachary Altaher. I am one of the security engineers.
I'm Nathan Kale, and I'm also a security engineer.
And our sponsor was Marshfield Clinic Information Systems. And with us here today, we have our 2 sponsors and contacts at Marshfield Clinic Information Systems, Brandon Wolf and Daniel Schmidt. We thank you both for being here, and we thank you all for being here. We hope you enjoy our presentation.
Today our agenda looks like this. First we're going to do a project introduction, then an overview of the network design and infrastructure, then a security overview, followed by a live demonstration, and end with the conclusion of the project.
Our problem statement for this semester is typed up here. You guys can read it, but I will summarize in that we were tasked by Marshfield Clinic to design a HIPAA-compliant network for an up-and-coming dental clinic, Stark Dental. Amongst being HIPAA-compliant, this network also needs to be very scalable and secure.
So first off, I'm going to be talking about HIPAA security. HIPAA stands for the Health Insurance Portability and Accountability Act. It is a government legislation put in place to protect PHI, or protected health information. PHI is any patient data that can be used to identify the individual. So this could be a person's medical cards, list of medications, basically anything you wouldn't want to be shared with anybody except your doctor. HIPAA is very important to the health industry, so I'm going to run through the who, what, when, where, and why of HIPAA. So first off is who is in charge of HIPAA. The U.S. Department of Health and Human Services, or HHS, is the federal department in charge of HIPAA regulations. What is HIPAA? HIPAA is federal legislation put in place to protect PHI falling into the hands of anyone not authorized to view it. This is done through numerous administrative, physical, and technical safeguards outlined by HIPAA regulations. When was HIPAA made? HIPAA was enacted in 1996 during the Clinton administration and is still in effect today. Where must HIPAA be enforced? HIPAA must be enforced at any health institution that houses PHI data. This of course includes Stark Dental and their patient data. And finally, why does HIPAA matter? In the event that PHI data is stolen or leaked, the HHS will find the health institution responsible based on infractions caused by not following HIPAA regulations. So, for example, back in 2014, the New York Presbyterian Hospital accidentally leaked thousands of PHI documents online through a simple human mistake. So, for the people affected, this meant that their personal information was online for anyone to see, and it made them an easy target for identity theft. The HHS reviewed this data breach and fined the hospital $3.3 million based on the infractions they incurred by not following HIPAA regulations. And this, of course, we do not want to happen to Stark Dental. So now that we know a bit about HIPAA, next I'm going to be talking about how we apply these regulations to our proof of concept. As I stated earlier, there are dozens of administrative, physical, and technical safeguards associated with HIPAA regulations. Due to time, we're not going to be able to cover all of these regulations and safeguards. However, we are going to highlight a few key technical safeguards that we put in place. More information about these other safeguards can be found in our written security policy and white paper. So we strove for our design to be completely HIPAA compliant. This means that during each step of development of our proof of concept, we went through each and every HIPAA technical safeguard to ensure full compliance. This means we have active directory-based authentication, with security groups determining what users have access to. We have a unique user identification schema with complex passwords that must be changed every 3 months. We have group policy-based monitoring and auditing tools on all of our accounts. We have secure certificates using a centralized certificate authority. We have a robust antivirus solution on all servers and client devices, and we have automatic log-off enabled on all client devices.
The rules we were asked for this project were to design and implement a fully functional network and server infrastructure, as well as design high and low level network topologies, which we will be showing you later in this presentation. We also needed to make a complete white paper documenting our proof of concept, as well as a presentation demonstrating that proof of concept and a written security policy.
Now, to make this proof of concept possible, equipment was lent to us by both Marshfield Clinic Information Systems and UW Stout. I'll go through some of that equipment now and how it lays out in our physical lab. So we have 2 Cisco 2851 ISR routers, 3 Cisco 3750 layer 3 switches, a Cisco 3650 layer 3 switch, a Cisco 2504 wireless controller, a Palo Alto 200 firewall, and 2 Cisco 3650 M3 servers. Now, that's how the equipment physically sits in the rack. It logically lays out in the topology that we have up here. I'd like to highlight a couple of things on this topology, first being the Internet Cloud. This Internet Cloud was provided to us by the UW Stout Lab Network. This serves as both our Internet connection and the connection we use for our interconnects between our remote site and main site. Looking a little closer at the main site, we have a DMZ subnet within. We'll get into that a little bit later and what that means. And then finally, I'd like to highlight the remote site and how it uses that Internet Cloud to connect back to the main site. So diving a little deeper into the main site, I'd first like to highlight that Palo Alto 200 firewall. This serves as our Internet Edge device as well as our security device on the network. Right next to that, we have one of our Cisco 2851 routers. This router serves as our WAN edge and is where all of our remote site traffic comes back into our main site network. Looking deeper into the network, we have the core. This is powered by 2 3750 layer 3 switches, and this is where the majority of the routing and switching takes place in our network. The majority of traffic on the network will flow through this core. Directly connected to that, we have our Cisco 2504 wireless controller. Now, the wireless controller is just located at the main site, and this powers all of our wireless devices, or wireless access points rather, across our main site and remote sites. I'd also like to show the Cisco 3650 layer 3 switch as our access layer, and more importantly, the DMZ or demilitarized zone subnets that are connected into it. These DMZ subnets are connected into the access layer here, but can theoretically be put anywhere there's a network port due to the VLAN segmentation we used and their termination at the Palo Alto firewall. Now that's a lot of technical terms, but in reality what it means is our protected subnets can ride right alongside our non-protected subnets and still provide the HIPAA compliance regulation protection we need. Now looking at our remote site, I'd first like to highlight the fact that there is no wireless controller here, but we still have those wireless access points. Now the wireless access points here connect back to that controller at the main site and use a technology called Cisco Flex Connect for them to function independently if the remote site were no longer connected to the main site and that connection is lost. This Flex Connect technology allows for patients and doctors at this new site to continue serving their patients even when there is no WAN connectivity. And lastly, I'd like to highlight our technology we use for that WAN connectivity, and this is DMVPN, or Dynamic Multi-Point Virtual Private Network. Now, that's quite a mouthful, I know, but it is actually rather easy to set up with just a few simple commands on the head end and on all of the remote sites. You can have a hub and spoke type topology or a full mesh topology WAN connection that is still HIPAA compliant and easy to install.
Stark Dental is in need of a major server infrastructure overhaul. First, we'll go into the hardware and software that we use. We use 2 IBM 3650 Model 3 servers, one at the main site and one at the remote site. Each have 16 hot-swappable hard drives, making it very easy to implement all the services needed for this overhaul and future updates as well. We use Windows Server 2016 as the operating system for all of these servers in our network, as well as Windows Server Hyper-V as the hypervisor, virtualize and manage all those servers and know compliance as well. There are several services needed for Stark Dental, the first being a robust and manageable Active Directory schema to effectively manage all of the user permissions on the network. They needed a functional DNS as well as DHCP to distribute all of the IP addresses to the clients and other devices on the network. They also needed all of their Windows updates to be distributed internally. This will be done through the WSUS role within the Windows Server. This role makes it very easy to distribute and test all of the updates for the Windows devices. And they also need a creation of a logical file sharing system to manage all of theirs and their patients' important information, especially the protected health information. And lastly, because they have created a new remote site, they need all of their essential services to be replicated from the main site to the remote site for redundancy and availability purposes. Just a little demonstration of what replication can do for a company. So there is the main site and the remote site for Stark Dental without replication configured. And if the main site servers were to go down, that would cause both sites to go down and it would not be able to effectively service their patients. But if replication was configured and the main site servers were to go down, then they would both be able to stay up and they would be able to service their patients correctly. So this is an essential service for Stark Dental.
Now, being that we designed a network for a dental clinic. Security was a big issue for us. We started pretty simply by setting some group policy objects. Now these GPOs are policies that we have set in place on our Active Directory server that get pushed out to the user no matter what device they log in. Now, since that's the case, we don't have to go to every computer or server on our network and make sure that these settings are configured. Most of these settings are auditing logon failure, and file access, since we have a lot of personal information on our network. Next thing we had to look at was encryption. Again, we have a lot of personal information on our network, so we need to make sure that that information is secured in case of theft or failure to decommission hardware correctly. So we went with BitLocker encryption. This comes standard with Windows Server, and since we were already running Windows on our network, we didn't have to worry about it interfering with anything that we were running. Another thing we were asked for was we needed to set up remote access. Since we were given a Palo Alto firewall, we used the Global Protect VPN feature of it. Now this allows remote access to our network from anywhere as long as we have internet connection. And also we needed to look at malware and viruses as an issue to make sure our network is secure. We want to make sure that they're not getting onto our network. We looked at a couple of different options and ended up going with Symantec since it was more tailored to a network of our size. Now what this is endpoint protection that's put on a centralized server and gets pushed out to all of our clients. So again, we don't have to go to every computer and make sure that this is configured.
So next, I'm going to be talking about firewall policies. In our network, we have a Palo Alto 200 firewall acting as an internet edge device. This means that all traffic over our network will pass through this firewall and can be monitored using the built-in monitoring tools. Our network is segmented out into multiple zones, like the internal zone, server DMZ zone, and VPN. In our firewall, we have 10 security policies in place based on these zones. These security policies limit where IP addresses can be sourced, which users can send traffic, what applications are allowed, and which ports can be used. So, for example, we have a user who's trying to send traffic to our internal network. The first thing this traffic hits on our network is the Palo Alto firewall. The firewall then reviews this traffic data and matches it against our 10 security policies. If it meets all 10 criteria, the traffic will be automatically allowed onto our internal network. However, if this traffic fails to meet a single one of these security policies, it will be automatically denied at the firewall. And any rogue traffic on our network can be monitored and exported as a report.
All right, so now we're going to run through a little live demo of some of the security features on our network. The situation we have today is Stark Dental has just hired a new person, an intern, and we need to create a user for that intern and add them to the correct security group. Now, when this comes in, our security people are on vacation, so they're going to have to remote into our network using our Global Protect VPN, which you can see Nathan connecting through here. And if you look at the bottom, you can actually see password expires in 27 days. That is because of the policies we've set in place that passwords need to be changed every 3 months to help us meet our HIPAA compliance. So here we are on our Active Directory server. This is our users and computers group where we create users. Nathan's going to run through the process of creating a user. Now this is a pretty simple process, as you can see him doing it here, but the important thing that we need to focus on is making sure that this user is put into the correct security groups. Now we have security groups set aside for interns already that allows them access to certain files that we deem necessary for them to do their job, but blocks them out of the personal information that we don't want them to have access to. So if you look here, you can see Nathan adding the intern to the security group, and now we're going to demonstrate this for you. We're going to go in to one of our client devices as the intern we just created. Now this is basically just if this intern would sit down at a computer and sign in using their user and login information. Here he enters it, and then we'll have the access that we need. And this will get, like I said, these policies we put in place get pushed out for the user. Now, we can access the files from our file server. You can see we have a folder called interns file. Now, we're allowed to access this folder, access the files in it, read the files, do saves, whatever we need to complete our job. But if we exit out of here and go back, you can see that there's a file for our protected health information. And if we try to access that, we actually get locked out due to the security policy we have in place. And now we're going to run through a little demo of some of the features of the firewall for you.
Yeah, as Zach said, we are next going to demo a feature involving the Palo Alto firewall. So as interns, we really don't want them to be browsing the internet or what have you, just doing their assigned work. So what we have done is create a firewall policy on our firewall that will block all traffic, all internet traffic to Facebook.com. See it up there. Now we can can test this by going back into the client device, still logging in as the internet. We go to Internet Explorer, we'll see that we can still get to the internet just fine. But if we were to go to facebook.com, we would not be allowed. Now we can go back into the Palo Alto firewall, go into the Monitor tab, we'll be able to see that the traffic from the client device to facebook.com is being denied very easily right there. So that concludes our live demonstration, and I will continue with the rest of the presentation.
So to recap, some of the ways we have tried to meet the HIPAA compliance for our network, as we've demonstrated in our presentation, is we protected our health information. We want to make sure that personal information isn't accessible by people who shouldn't be accessing it. We've added our users to security groups to help protect that information, as well as lock down our traffic on our network through use of the firewall. We've also put out endpoint protection to protect from malware and viruses, and we've also encrypted all the information on our network to make sure that that information is as secure as we can possibly make it.
Hours worked on this project, we have around a total of 367 with a group weekly average of 33. As you can see by our ski slope graph that we indeed had some moments of distress during the last few weeks.
Yeah, that segues right into my lesson learned. Don't procrastinate on critical systems. One might assume by the title critical system they would kind of be self-explanatory, but we did find ourselves at one point with a critical system that was not fully in place, and it did set our timetable back quite a bit, as you could see by that ski slope of the graph. So I guess the takeaway from here is really time management.
Another lessons learned is that communication is very important, especially working on such a large-scale project over such a long period of time. Me personally, I've worked on a project for this amount of time, and just the amount of communication that needs to go in between group members and other people involved in the project is really just immense. And I just want to emphasize the importance of communication, what it can bring to the success of a project.
Something I think we definitely all learned was security can be a pain. I know that can sound a little weird seeing as security was such a big part of our project, but there were many weeks in which what normally would have been a simple implementation turned out to be a major headache due to a simple security measure we implemented the week prior. This led to many long nights of hair-pulling troubleshooting, just trying to figure out how to work around a security measure we put in place ourselves.
So to build off what Nathan said with security being a pain, endpoint protection is something that I and we as a team have never encountered, never actually had to implement. And I know for me personally, I thought it was going to be one of those simple services you set up on a server and it just pushes out to your clients. But there's actually a lot that goes into configuring endpoint protection, and it has to be set just right. And if you don't have it set just right, you can very easily bring down your network, which leaves you troubleshooting for hours or days trying to figure out why your network's not working. And I mean, as you can see by the hours on our timesheet before, that might have happened towards the end there, once or twice with us.
Well, thank you all for enjoying our presentation with us. A special thank you to Marshfield Clinic Information Systems and to Brandon and Daniel for your support throughout the semester. I'd also like to thank the UW Stout CNIT Advisory Board and all that they do for our major to make it what it is. And finally, I'd like to thank Holly for her help, especially in this last semester. Capstone's not easy, and we appreciate your support throughout the process. So we now have some time for questions. We'd like this to be a conversation, so if you have anything to ask for us, just let us know. We'll definitely try to answer that for you. We have about 5 minutes. The floor is yours.
Yeah.
I can throw one out. Great job, by the way. Great presentation.
Thank you.
No one's going to be back next week. Questions, I don't know. I work for a Cisco partner, and I couldn't help but notice that you were using a 2800 series router, and that router's been end of life. It's about a year past its end of life. So I was kind of curious if you could perchance take a note of that, or maybe advise them, because the building systems, we want to make sure that you're running them support.
We work with the equipment we were given.
Yep.
The Cisco 2851 is end of life, but the licensing on there, of course, due to its older model, is a lot easier to work with, and it was still a capable router for our labs. Yes, though.
I've worked with healthcare organizations. I understand what a big job it can be to do hardware upgrades. It takes a long time, so I totally understand.
Yeah.
On your topology diagram, your EMDPN line of router was in parallel with your firewall. Can you talk about your decision to not put that behind the firewall, and what measures you took to secure it?
Sure. The decision on that was simply to have a WAN edge that was locked down simply as just WAN. We have access to this on the inbound interface that will allow traffic from the select remote sites, external IP addresses to be allowed in. Theoretically, it could have been behind the firewall, as the firewall being a single entrance point to the network. I guess in reality, both of them are capable and workable solutions. This is just the one we need. All right, well, thank you all again.